Alright, so today we're going to be looking at two-step specific heat capacity problems, a little bit different from what we did yesterday. The main difference is because we have two substances in the problem as opposed to just one that we looked at yesterday. So I'm going to show you how to break down one of these problems and hopefully be able to solve them on your own. So if you will read the problem silently as I read it aloud, it says a student heated 91.4 grams of an unknown substance to an initial temperature of 220 degrees Celsius. The student then placed the unknown substance into 500 grams of water with an initial temperature of 25 degrees Celsius. After 10 minutes, the student recorded the final temperature of the water containing the unknown substance at 28.7 degrees Celsius. Using the data table provided, find the identity of the unknown material. Assume that no heat was lost within the system. So to kind of break down what you see here, I gave you a little illustration. You can see we have the unknown substance with its initial temperature. So the student heated it to this first. And here's the mass of that substance. Here's the water, 500 grams of water, and its initial temperature of 25 degrees. So the student took this hot substance, placed it in the water, and then after 10 minutes, this is the temperature that they recorded of the substance submerged in the water. And so hopefully we're going to do some math here using this information to find out which substance is the unknown. All right, so what I like to do first is I like to take my two substances and organize them into a type of chart like you see right here. And I want to go through my problem and see if I can find these variables, and we'll see what's missing, and that hopefully will give us the clue to solve the problem. So I want to look for Q first of my unknown substance. So I'm looking for joules, which is the unit for Q, just J by itself. And if you skim through the problem, you won't find joules anywhere. So we're going to skip that for now. So now the next variable we go to is mass. So I'm looking for mass of the substance. I find it right here in the beginning of my problem. It's 91.4 grams. All right, my C of my unknown substance, that unit is joules per gram degree Celsius. And I don't think I see it in here either, so we're going to leave that alone. All right, and then change in temperature, delta T. So, well, I look at my illustration over here. I have an initial temperature of the substance, and I also have a final temperature of the substance. So I have two temperatures, so I can find delta T. Remember, we find that by subtracting final and initial. So if I do that, my final is 28.7 and my initial is 220. I can do that and get a delta T of negative 171.3 degrees Celsius. All right, and that should make sense because the substance was very hot to begin with. It's got this high temperature, and we put it in water, and all of a sudden it cooled down. Okay, so we got everything we can find for the unknown. Let's look at water. Joules of water, I don't see that anywhere in my problem, so I'm going to skip it. Let's go to mass of water. So I look over here, there's my mass, 500 grams. All right, C, specific heat capacity of water, that's the number that you're supposed to memorize if you remember it from yesterday. Does anybody know what it is? Okay, that's 4.18 joules per gram degree Celsius. All right, and then delta T. Well, I've got an initial and I've got a final of water, so I can calculate that. That's going to be 28.7 minus 25. And I get a temperature change of 3.7 degrees Celsius. All right, so I've got all the information from the problem that I can. And if you look at what's given to us, we're given more information about water than we are of our substance. So let's see if we can find this variable right here for water. Maybe that'll help us solve the problem. Okay, so to find Q, I'm going to look at my formula right here. There's my triangle. There's the formula that we taught yesterday. To find Q, I'm going to multiply mass, specific heat capacity, and delta T. So these three numbers right here, I'm going to multiply them together, and that's going to give us my Q. So I get a Q value of 7733 joules. Now, it is important that yesterday we learned, when we were talking about this formula, is Q. Q is heat energy that can be lost or gained, depending on the value that you get for Q. Well, I plugged it into my calculator and I get a positive 7733. So that means that water gained 7,733 joules of heat. Well, the big question is, where did it gain the heat from? That's right, it gained it from the unknown substance. So since water gained this much heat, the unknown substance had to lose this much heat. Again, we're assuming that no heat was lost outside of the system. Well, now that we are able to plug in our Q for the substance, we have everything we can to solve for C. All right, so yesterday we learned how to manipulate this to solve for C. C is equal to Q divided by M times delta T. So I'm going to plug all my information in here and let's see if we can solve this. So Q is negative 7733 divided by, and I like to use my parentheses here, 91.4 times negative 191.3. So let's plug that in here, negative 7733 divided by, parentheses, 91.4 times negative 191.3. And we get 0.44 and some change, okay? And that unit is joules per gram degrees Celsius. So now that I have this number here, I want to see, does it match something in my data table? And lo and behold, we look over here, we get a perfect match. So the substance that was submerged into the water was nickel.